Okay, on these, I'm just going to warn you, they can be a little tricky, so I will give you multiple choice answers for these. I think that will make you happy. We need to eliminate one of these variables. So 2x, 5x, that doesn't automatically eliminate. Y or 3y, again, doesn't automatically eliminate. So I can multiply this whole equation or this whole equation by any number I want, as long as I do the same thing to one side as I do to the other side. So I'm going to multiply this entire equation by a -3. Why did I pick a -3? Because if I get a -3y, it will cancel out the 3y from my second equation in my system of equations, and then I will be able to eliminate one of my variables. So I have to do this to every term in the equation, okay? So -3 times 2x is a -6x. A -3 times y is a -3y. And a -2 times a -3 is a +6. Now this is now my converted first equation. I will put my second equation underneath it. Now, I've got a negative and a positive. I can simply add those two together to eliminate my y term. So I'm going to add these. I could have just multiplied by a +3 and then I would have had to subtract down here. But I like to go ahead and multiply by the negative so I can add, so I don't have to worry about my negative signs. All right? So I've got a -6x and a +5x. That leaves me with a -1x. Obviously, this all cancels. A -3y plus a +3y. And then that all equals 6 plus a -8 is a -2. Now I'm solving for x, not a -x. So I'm going to divide both sides by a -1, and I get x equals 2. So there's my first variable. Now I'm going to take this 2 and plug it back into one of my original equations. Nothing that I adapted or amended or anything. So I want to put it back into an original equation. And my original equation was 2 times x, which is 2, plus y equals a -2. 2 times 2 is 4, plus y equals a -2. I'm going to subtract 4 from both sides so I can get y by itself, and I get y equals a -6. So my ordered pair, x always goes first. I think some of you are getting confused. You always have to put x first, then y. An ordered pair works that way. Now, I insert both of these back into both of my equations from my system of equations. This has to work for both of them. So let's say 2 times 2 plus a -6 equals a -2. 2 times 2 is 4 plus a -6 equals a -2. -2 equals -2, and check. That was my first equation. Now let's put it in my second equation. 5 times 2 plus 3 times a -6 equals a -8. 5 times 2 is 10, plus 3 times a -6 is a -18, equals a -8. 10 plus a -18 is a -8, equals a -8. Check. I am confident that this solution works in this system of equations, or it works in both equations. Now again, what do I pick up here to multiply by? I don't just pick any arbitrary term. I pick something that when I multiply it by my equation, I will get something that eliminates. And in this case, it was my y's. All right? Let's try another one, because these are tricky. Okay? I have 2x plus a negative 6y equals 12. And I have a negative 4x plus 15y equals a negative 30. Now, a 6 and a 15, that would really be awkward to do anything with. But it would be very easy to multiply this 2x by 2 to get 4. Now, I can't just pick one term. I can't just pick one term and multiply it. For me to change this term by multiplying it times 2, I have to multiply this times 2 and this times 2. Everything has to be multiplied by 2. Everything, each term in the equation has to be multiplied by 2. So it still balances. Okay? So here we go. 2 times 2x is 4x. 2 times a negative 6 is plus a negative 12y. And 2 times 12 is 24. This is my new or revised first equation in my system of equations. Now I'm going to drop down the second one, which is a negative 4x plus 15y equals a negative 30. My terms are opposite, so I'm going to choose to add those together because positive 4x plus a negative 4x is going to give me 0. And like I said, I tend to like to add rather than dealing with all those negative numbers. All right? So 4x plus a negative 4x is 0, so nothing there. I've eliminated my x variable. A negative 12y plus 15y is 3y. And 24 plus a negative 30 is a negative 6. I will divide both sides by 3. I will get y equals a negative 2. So I have got my y variable. I'm going to plug that back into one of my original equations. I have to pick an original one, and I'm going to pick the top one. So I have 2x plus a negative 6 times my y, which is now negative 2, equals 12. 2x plus a negative 6 times a negative 2 is a positive 12 equals 12. I'll subtract 12 from both sides because I want to get my variable by itself because I'm solving for x. I get 2x equals 0. I divide both sides by 2. I get x equals 0. So my ordered pair is going to be x goes first, 0, then y, negative 2. Now, for me to check, I have to put this solution into both of my equations in my system of equations to check. So I'll start with my first one. 2 times x, which is 0, plus a negative 6 times my new y, which is negative 2, equals 12. 2 times 0 is 0, plus a negative 6 times a negative 2 is 12, equals 12. 0 plus 12 is 12, equals 12. Check. Now I'll plug both of these values into my second equation in my system of equations, which is a negative 4 times 0 plus 15 times a negative 2 equals a negative 30. A negative 4 times 0 is 0 plus 15 times a negative 2 is a negative 30 equals a negative 30. 0 plus a negative 30 is negative 30 equals negative 30. And check. We are good to go. Now, what would happen when I'm done solving if I come up with an answer that says, 4 equals 4? both of my variables have canceled out, and all I'm left with is 4 equals 4 for an answer. That is a true statement. If it is a true statement, then I have infinitely many solutions. Just like when we were graphing, just like when we were doing solving systems by substitution. Okay? However, if I come up with an answer like 0 equals 7, that obviously is false. And if I come up with a false statement because all of my variables happen to have canceled out on one of my problems, they all canceled out, my x's canceled and my y's canceled, and all I'm left with 0 equals 7, that is a false statement, and I would have no solution. Again, this step is exactly like what we had when we graphed and we had 2 lines running parallel. They never intersected. Or we got 0 equals 7 when we were doing substitution. That means these 2 lines, these 2 systems of equations never intersect or never have a common point. So they would have no solution. No solution. It is false. This one, when we were graphing, our first line would be this, and then our second line would be right over top of it. And so every point that one line touched, the other line touched, going on forever and ever into eternity. So it would have infinitely many solutions. Or, just like when we were solving with substitution, if all of our variables canceled out, our x's canceled, our y's canceled, and we were left with 4 equals 4, it was a true statement, we would have infinitely many solutions. Okay? All right, guys.